Hi, in this lesson I'm going to be discussing and going over examples of trig identities known as sum and difference identities. The proofs of these are provided in textbooks and online, and I'd encourage you to look at them and read over the proofs to see how they come about. There's a geometric argument used, and they arrive at 6 different identities, 2 of them each for sine, cosine, and tangent. And if you notice, the a plus b is a reference to angles. So a sum of 2 angles or a difference of 2 angles. 3 formulas involve sums, 3 involve differences. And so what these would allow us to do is take something like, for example, 75 degrees, that we don't know as a special angle and can't resolve without a calculator, and instead write it as the sum of 2 angles that are more convenient for us. 30 and 45 are special angles that we know the ratios for. I expand according to the pattern in the identity this way, and I rewrite as factors using sine and cos of 30 and 45. Then I replace with ratios that correspond to those values. And then I just do the algebra. At that point, notice that both denominators have 2 root 2 in common. And if you do these right, you will always have a common denominator, so you don't need to worry about that part. Now, these final solutions are often simplified by rationalizing. In this case, it would produce a denominator of 4 and a numerator of root 2 plus root 6. So, we're going to look at a few different examples of how these identities get utilized. First up, there are a list of other identities for cofunctions, which refers to how sine and cosine, for example, relate to each other, and odd and even identities. We can use the sum and difference identities above to show that some of these are true. For example, the sine of negative a could be written as the sine 0 minus a. The expansion of that would be sine 0 cos a minus cos 0 sine a. Sine of 0 is 0, so we replace that. Cos of 0 is 1, and we replace that. And we see that this simplifies to negative sine a, confirming the identity above. This is one example of how a sum or difference identity can be used. Now, here are 2 other examples, similar to what I started with a short time ago at the start of the lesson. Find the exact value of this degree measured sine function and cosine function in radians. So we want to think about 195 using a sum or a difference. Now, I could say something like 180 plus 15, but I don't know 15 is a special angle, so that's not very helpful. I could call this 150 plus 45. 150 has a reference angle of 30, therefore it's special and we know its ratio, so does 45. This could work. There are often multiple examples. You may want to think about another one and see if you can find it. Use the identity above and see now if you can rewrite sine of 195 and then rejoin me. Okay, here's the final solution for this. I rewrite using a sum identity for sine. So sine 150, cos 45, cos 150, sine 45. Note that I could have written 45, 150 in the other order. I would have got all these same factors just reversed, so it really doesn't matter which way that you write it. Then I write the corresponding ratios that I know from the special angles and simplify and rationalize. Now give 11 pi by 12 a try. A hint before I ask you to pause is think of 11 pi by 12 as a sum or a difference of other values that are pi by 12 based, but that would simplify to special angles. Here are 3 possible options. Notice that pi by 12 is not helpful, so this first sum, though it's correct, isn't helpful, while the second and the third are. I'm going to choose this second one and work with that. So I will write this as cosine, pardon me, 9 pi by 12 cosine 2 pi by 12. I'm using a plus here, so in the cosine identity I subtract. Then it's sine 9 pi by 12 sine 2 pi by 12. Now, 9 pi by 12 is really 3 pi by 4 when simplified. A little easier to see that way. 2 pi by 12 is pi by 6. So we'll simplify all of these reduced form radian measures. Then we will replace them all with the corresponding ratios that we know. For this, it is negative 1 over root 2, quadrant 2. This is positive root 3 over 2. This is positive 1 over root 2, and this is positive 1 over 2. Again, I've got my 2 root 2 denominator. My numerator is negative root 3 minus 1. I will rationalize, and I'll write the final result, denominator 4, numerator negative root 6 minus root 2. All right, a different type of question that can be asked. In this case, you were given sine of an angle A, negative 1/3, quadrant 3, cos of an angle B, negative 1/4, quadrant 2. Hopefully by this point, the idea that would come to mind to you is to write these in standard position and see what information comes. Do that while you pause, then rejoin me. Okay, here are the standard position values, and we see that we can find the x-coordinate of negative root 8, or negative 2 root 2, when simplified, and for the angle B, the root 15. The next step in this problem would be to look at what you're asked for, use an identity to rewrite it. Do that, and see how far you can get, and then come back and rejoin me for the solution. Okay, here's the solution. I rewrote the cosine identity using cos. Because there's a minus, I'll write plus, and then sine. Now, cos A can be figured out from the standard position diagram. That's why it was important. Sine A was given in the question. The other two ratios are known, leading to this result, which is rationalized and produces this result. Okay, try tan A plus tan B, then rejoin me. Okay, this is the identity for tangent with a plus, tan A plus tan B, 1 minus tan A tan B. Tan A is 1 over 2 root 2, tan B is root 15, and it is minus, so I'm adding a negative or subtracting. Now, the common denominator is the 2 root 2, so I'm going to rationalize by multiplying by that, and I'm going to get 1 minus 2 root 30 over 2 root 2. This is subtracting negative, so plus root 15. So I do still have an irrational denominator. To simplify that, I would multiply by 2 root 2 minus root 15, the conjugate. And the denominator is a difference of squares, so it's 2 root 2 squared, which is going to be 8, and then root 15 squared, which is 15. And the numerator is 2 root 2 minus root 15 minus 4 root 60 plus 2 root 450. And it doesn't look like there's any common factors, so I can simplify the denominator as negative 7, or change the sign of all the numerator terms. So I'll call this positive root 15 plus 60's got a 4 factor in there, so I'll liberate a 2 root 15, that's plus. The 2 root 2 is now minus 2 root 2, and the root 450 is 45 times 10, which is 9 times 5 times 5 times 2. So I've got a 9 and a 25, so a 3 and a 5 will come out, or a 15 times 2. So I have a 30, and I'm left with a root 2. So I actually can get this a little bit simpler. 9 root 15 plus 28 root 2 over 7, unless I made a math mistake doing that too quickly. You should probably check your work and just make sure I did that right. Okay, one more question. An equation to be solved conditionally, so 0 to 2 pi, and I'd like you to just have a look at it, and hopefully you can recognize, especially because of the topic we're on, that this left side here relates to the identity for a cosine double angle, or a cosine sum, rather. And the reason I say sum is that there's a minus sign there. Again, look back at the identity if you're not seeing that. So I'm going to rewrite the entire left side with that expression, cos of theta plus pi by 5, 1 over root 2. The 1 over root 2 for cosine as a reference angle of pi by 4 in quadrants 1 and quadrants 4. Theta plus pi by 5 is my angle. So theta plus pi by 5 needs to equal pi by 4, or theta plus pi by 5 equals 7 pi by 4. And now I solve for theta. I need a common denominator of 20. This will be 5 pi by 20. Subtract 4 pi by 20. So one angle is pi by 20. The other angle, 20 denominator, multiplied by 5. 20 denominator, 4 pi by 20. Subtract 31 pi by 20, my other angle. All right, good luck with this lesson on sum and difference trig identities.